So protecting processes from each other and protecting the operating system from untrusted process code, same exact mechanism. The page table, when you're running in user mode, doesn't allow you to go to any physical pages that belong to the operating system, is really done through this memory management that we just talked about. The memory management is important enough that we actually hardware provides support for it. Typically, you have what is called a memory management unit or MMU that helps you take those logical or virtual addresses and resolve those into physical addresses efficiently. I said we had to read, go through the page table. Well, then to access memory location, you have to access a page table entry. That adds overhead. So the hardware actually can store some of that. Things called TLBs or translation look-aside buffers that are associative memory that allows you to do this mapping fairly efficiently. So memory management, this translation and isolation, what you can access and all that, there's hardware support for it. So there's another interesting thing that we should be able to think about here. So we have these units we call pages or frames, and we have this table we call a page table. And we say we go through a page table entry to see where our logical page currently lives in physical memory. So that page table entry tells us where in physical memories. But we can have some other information along with that. We can, for example, have whether this page that we're trying to access is for reading only, is it for writing, or it's for execution only in case it happens to contain instructions or code. So you can actually have this kind of protection information on these pages in the page table entry that can limit the type of memory access you can do. So we said protection, now we are saying there are two parts to it. First part is where in memory a given process is allowed to go. So where can its logical addresses be translated to in physical memory? But now we're also saying another level of protection is in what manner can it access, even if it's allowed to access a given location in physical memory. Is it reading only? Is it writing only? Is it execution and things like that? So the way we do that is in the page table entries, we keep this information, this protection information about the ways in which memory can be accessed. And that is also used when you're trying to do, let's say, store and the target address is write protected. You can't do that. That instruction would not be allowed to go through by the hardware.